All right, good morning, everybody. This is Mr. Walker here, and we are talking about special solutions. So this is the final part of this section. And, at times we're going to be looking at kind of crazy things when we're solving algebraic expressions. So we want to make sure that we're prepared for that craziness ahead of time. So first off, let's look at these first couple of blanks. So the solution of an equation is the values of the variables that make the equation a true statement. Now, since we're dealing with one variable right now, equations in one variable can have one solution, infinite solutions, or no solutions. So these are the times where you might see a little, craziness happen when you solve an equation and you happen to see that either your variable gets canceled out or you see that you end up having your variable equal itself. I mean, all types of craziness. If you end up seeing things like that, you probably have freaked out in the past. So today we're going to end up talking about that stuff so you don't have to freak out further. All right, so there are three different types of solutions that you will see. Either you're going to have one solution where it's just one thing equaling something else. You're going to have infinite solutions. That means that anything could work for our variable that we have, or you're going to have no solution, which is really a situation where you end up canceling out your variable. So let's deal with each of these. So for one solution, that means that there's only one value that makes the equation true. And because of that, that means that there's only one number that works. Other than that one number, nothing else works for it. For infinite solutions, any value can make this equation true. And that means that any number can work. So these are just, the critical things that you want to think about when you're going through and solving this. And then for no solutions, that means that there is no value that can work for this. Nothing can make this equation true. Don't even worry about it. That means that you have to go through and move on because that is, truthfully the only thing there. So no number can work for this. So one number could work, any number could work, or no number. Okay? All right, so in this next column, what can be a true solutions for these particular situations? So if you have one solution, you can sometimes have a solution. Sometimes you could have a true solution. What that means is there is a conditional equation and it is true for some values of x. So for an equation that has only one solution, that means that there's only going to be some values that work for it as opposed to other values. So underneath this, we just want to make sure that we understand this means that it is only true, and it is only true only one time. Actually, there's one time. Okay? So don't worry about any other times. This means it's only true for one time as we're dealing with it. All right. For infinite solutions, this means that there are always going to be a true solutions for it. That means that there's always going to be a number that is true for any value that you plug into your variable, whether it be x, y, k, whatever. So this means that it is true every time. Doesn't matter what you plug in there, it's always going to be true. And then for our next one, this means that there is never a value that makes it true. Okay? This means that there's going to be just something crazy there. You're just going to something like 0 equals 1 or 5 equals 3, things that you know that doesn't make any sense. So a contradiction is never true for any value of x. So not ever true. So it's only true for one thing, it's true for everything, or it's not true for anything. So we got some examples underneath here. Now, I know right now this all seems pretty crazy, but you're going to see what I mean right now and how this works. So let's look at this first one. Pretty simple. We got an equation where it's 4x plus 6 equals 18. So let's deal with the first part. We want to bring that 6 over to the other side so we can get this x by itself. So we got 4x plus 6, and then we're going to subtract that 6 over to the other side. So let's put that minus 6 there. Now over here, what's left over is we got the 4x on this side, and then on the other side, I got it equaling 12. Now I know I got to go through and do my division, so I got 4x over here divided by 4, and on the other side, I got 12 divided by 4 also. And that just leaves me with x equaling 3. Let me space that over. Equal and 3. Okay. So we go through, we solve this like how we've done before. Now, because x equals 3, this means that 3 is the only number that'll make this equation true. Anything else, it's not going to work. So if you try plugging in 4, 5, 6, not going to work for you. So let's take a look at this equation here. This equation, when we look at it, we got 15 plus 5x equals 5 plus 15x. Now, off top, you might notice that both of these sides look the same. So even if you went through and tried to simplify this, like by bringing the variables to one side or the constants to the other, at some point, you're going to notice that this side, if you try to bring over the 5x's, like if you did 5x minus 5x, you'll be left with 15 equals 15. Or you would be left with 5x equaling 5x, which basically means that either way, if you went through and brought everything to one side or the other, you'd probably even get a case where you'd have 0 equaling 0. What this means is that for any value that we're going to plug in here, any number could work. So I could plug in 1 and this equation could work. I could plug in 2 and this equation will work. Because really this and this are both the same once I've simplified it all out. Now, for this last one, we see something kind of similar to this where we're noticing, oh, over here I see I got 4x. I see I got 4x here, but we notice that these things are different. So if I try to move the 4x's to the other side, I'm going to notice that my 4x over here would cancel with this 4x over here. So you would end up in a situation where you would have 8 equaling 3. And that's crazy. That doesn't make sense. So in cases like this, we know that there is no number that can make this equation true. Unlike this previous one where we had the same thing on both sides, if we have only some things that are similar, like these x's, that makes it so when we go through and try to solve this, we try to bring all our variables to one side, all the constants to the other, our variables will end up canceling each other out. And that's not going to help us to solve anything because we already know that everything else over here isn't equal to this. So that just lets us know there's nothing that could work for this. So a couple of hints that you're going to look at this. The end result for something that has one solution is a variable and a solution. So you're going to notice like how we did in our example, there's something over here, there's a variable, and there's a solution on the other side. Now, over here, if we're dealing with infinite solutions, variables are going to cancel out on both sides of the equation. And what that's going to mean is that they look equal. So if you look at the beginning, they both look equal. There's nothing over here that we need to simplify. Same thing over here. And when you look at it, you got the same stuff on both sides. Now over here, variables cancel out on both sides of the equation. And this lets you know that they don't look equal all the way. I would want you to know that they have the same variables, but different constants. And I'm gonna make sure I just, pull this out a little bit so it can, show up in a way that you could see. And there we go. So for situations like this, you'll have the same variable but different constants. Now, over here on the right, we got a couple of examples that we're going to work out. So I'm going to let you guys check out the next video for this. But right here, these are our baseline just definitions as we're going to go through this. So I'll catch you in the next video.